Right, this is paper 6A of your key assessment, question 4. And we've got an ovary during ovulation. So this is part of the ovary, and got primary follicle, and this was a secondary follicle, but now we've actually got ovulation taking place. And we've got our secondary oocyte, or the egg, after ovulation there. Describe what subsequently happens, so what happens after to the following, the secondary oocyte. Where's that gonna go? So that goes into the fallopian tube or the oviduct, where fertilization may or may not happen. So passes into the fallopian tube or the oviduct. I prefer fallopian tubes, it sounds much better. And what's going to happen to this Graafian follicle? Well, that is going to become something with a new name that's going to produce hormones and so on. So we just need to remember that name. So develops into the corpus luteum. So pretty straightforward so far. Describe how the hormones FSH and estrogen illustrate the principle of negative feedback in controlling ovulation. So again, we're just trying to think about our female hormonal regulation cycle now. But we need to make sure that we talk about negative feedback and this bit controlling ovulation. That's a bit that people will forget to write on the end. So, for example, I always remember it as FOLP, FSH, estrogen, LH, progesterone. So, FSH stimulates the production of estrogen. So FOLP. So FSH leads to the next one, O, estrogen. So that's going to leave us our first mark. And then we've got this negative feedback going back. So estrogen will now inhibit our FSH. So estrogen inhibits the release of FSH or production of SOH, or words from that, from the anterior pituitary. So they're actually going to give you another mark for remembering where it's from. And that leads to our negative feedback now. So that is going to, if we've got less of our FSH, well, there's going to be less stimulation of estrogen again. So that's our next point. So this reduces the production of estrogen. That actually is our negative feedback. So low levels of FSH mean there's low levels of estrogen being released. And don't forget this last bit of the question, it says in controlling ovulation. And so that now will allow ovulation. So this now allows ovulation, so we haven't got much FSH. Explain why estrogen may therefore be used as a contraceptive. So we might not know that much about contraceptives, but we can just use the hormones and what they do. So if estrogen inhibits FSH, then whatever FSH does isn't going to happen, and that's pretty good if you're wanting that as a contraceptive. So estrogen inhibits the release of FSH, and now does what it says on the tin, follicle stimulating hormone. Well, follicles ain't going to get stimulated, and so in terms of use as a contraceptive, that's pretty good. So without FSH, the follicles do not develop. So there's 2 marks so far, and then fertilization won't take place because we won't get the next parts in the cycle as well. So so if no, can't spell no, if there's no follicle, this Graafian follicle that's going to get developed there, so if no, for example, Graafian follicle or mature follicle, there will be no ovulation, so no fertilization possible. So that's what we're aiming for as a contraceptive. So no matter how many sperm are available, there's going to be no follicles that get developed and released. Part C, an amusing diagram here. For use as a contraceptive, estrogen can be incorporated into a porous patch, which may be applied to the arm. Okay. The diagram below is a schematic map of the human circulatory system. Okay. And using numbers and letters for the chambers of the heart, describe the route that estrogen would take from the patch to the organ. Right, what is the organ that it would have its effect? Well, the bit of knowledge it's testing is the structure of the system here, circulatory system, and where does estrogen have its effect? Well, it's having its effect on FSH, so that is going to be in the brain, in the pituitary, anterior pituitary. So arm and pituitary. Where's the arm? Where is the arm? There we are. Forelimbs. That's where we're starting, and we're going to the head and neck, aren't we? Okay. So, forelimbs, we are disappearing off with a deoxygenated blood. That's going this way, and that's going to go into the heart, the right atrium, down to the right ventricle. Then it will go into the lungs, either the right lung or the left lung, doesn't matter which one. Out of the lungs into the left atrium, left ventricle, out. This is the aorta now, and then it splits either way, but we're going to the head and neck, aren't we? So we'll go, that will be the route that takes. So we just need the numbers for that. So we are starting off with 2, then we've got 3A, then we are into our right atrium, right ventricle, 13, which is our lung. I don't think you need to write lung there. So he just wants letters for the heart, doesn't it? So lung, but don't worry about that. Then we are at 4 here, which is our pulmonary vein. So 4 pulmonary vein. Then we are into our left atrium of the heart. Then we've got the left ventricle of the heart. Then we've got our aorta, which is 12. And then finally we are into our artery, the carotid artery, is it? Which is 10 anyway. So AO2, interpreting our knowledge in this kind of new situation. All correct for 2 marks. One mistake is -1, then you're quickly into 0 territory after that. Apart from containing more estrogen, so forget about estrogen, describe one other difference in the blood leaving the patch and arriving at the target organ and state where the change would have taken place. Well, we are in a vein, and then we're going to the heart, then lungs, then we're in an artery. So if we say it like that, then you can probably guess what the change is. So part of this mark is going, well, it's going to go via the lungs, so it will get more oxygen, and the change takes place, more oxygen in the lungs. So again, just applying our knowledge to this situation, AO2.